Yeah, so today I'm going to talk about three things. I'm going to talk about monitoring of insect pests, then monitoring of plant diseases, and the last thing I will talk about is the monitoring of weeds. So let me start by presenting the first part, which is monitoring of insect pests. So let us focus on insect pest monitoring for timing of control measures and insect crop yield loss models. So what is pest monitoring or insect pest monitoring? We would want to determine the distribution of pests in cropping areas. We also want to monitor in fact, the importance of monitoring is that it can be used to forecast pest outbreaks. And we can use things like traps so that we can catch the insect pests. So we have got reliable estimates of pest incidents when we sample area. If we focus on certain areas of our interest, we may create a bias in sampling. So we should try to look for a representative area, probably which represent the farming system which we are interested in, so that we can sample the insect pests. Here I've just put a diagram showing you different kinds of insect pests. So there are various ways of catching these insects. There's this malaise trapping, light trapping, bunny trapping, pitfall trapping, use of beating sheet, acoustic monitoring, probably use of sound. Or we can actually conduct some surveys where we move into the field and visually look for these insects. So we can have active visual assessments so that we have an idea about the insect pests. Now there are three sampling techniques which can be used. First, we can use random sampling. Second, there's stratified sampling. There's also systematic sampling. Now let us look at what we can be doing when we use random sampling. Now, in this exercise, every sample has an equal chance of being selected. We can use coordinates selected from random number tables. Second, we can use a stratified sampling. In this case, we divide the sample into different parts or strata. Then within the different strata or parts, we do random sampling. A strata is just a subdivision of samples. Then we can also do systematic sampling. Where taking samples can be done at fixed positions. We can take samples at specified distance intervals. Now, sampling can be done using a W pattern in a given field. So you can move in a sort of a zigzag way, sampling these insects. Here we have got a square field, and we have got these positions which we can sample. On our right, we have got a long, narrow field, which we can also sample like this. Probably these are random samples. Insect pest is the sample size, because the sample size is very important. It gives you the population estimate. We also have what we call absolute estimate. Now, when we are looking for these insects, we can count, we can have an insect count per unit area. So probably you may use a quadrat so to define the area, or you can use volume, or plant parts, or plant. For example, it could be the number of eggs per leaf, number of larvae per plant, reflecting probably the sample size. Now, we can also use a relative estimates of insect pest populations. We can use traps. Traps can actually probably attract the insects, and we can easily count them. Or we can use hormones, pheromones, which can attract these insects. We can create active and capture areas. I must emphasize that the trap data or the insect counts which we do after trapping the insects would be so variable that sometimes it's difficult to interpret that data. There are some of the terminologies which we should be familiar with when we are dealing with insects. There's a characteristic known as fecundity. This is the number of eggs produced during the lifetime of the female insect pest. We should also note the development and the growth of the insect. There's also the issue of movement of insects for long distances, which is referred to as migration. So in this picture, we've got somebody who is trying to trap the insects so that we have an idea about what sort of insects are present in a given field. This could be your crop, and you can put these yellow stickers which can trap these insects. Probably after some time, you need to identify and count these insects. Again, these are gadgets which are used to trap insects. There's also this gadget which is also used to trap insects. Probably people can improvise in making simple traps. For example, this one, where you have this bottle inverted in this container. You can see all of these trapped insects which have to be counted. So what are the monitoring strategies and the objectives? Now, in monitoring, we can use surveys. We can do field-based monitoring strategies. We can also do fixed position monitoring strategies. So let us focus on the survey. If you conduct a survey, you want to determine the status of a particular pest in an area. You may have to record the environmental factors. You can also use the data which you obtain in a survey to predict future infestations, or what we call pest forecasting, after conducting a survey. Now, there's what we call field-based. Probably the survey is targeted on a bigger area, but there's a field-based monitoring strategy where you target particular fields or certain fields of interest. These can provide the farmer with information which can be used as a decision-making tool. So the basis of what is found in the field in terms of numbers of insects can determine whether control measures should be taken. Sometimes we talk of a certain population of insects, which we call economic threshold, which justifies probably the spray of pesticides. The field-based sampling techniques can use traps, which I have, like some of these which we have talked about. So they can use traps, or we can actually count eggs and the larvae. These are certain stages, growth stages of insect pests. So the data on insect pests could be used to decide insecticide applications. Now, instead of just doing routine pesticide applications, we can be guided by insect populations to schedule insecticide applications, which becomes economic. Then we have fixed position monitoring. This technique is restricted to mainly research stations, where traps are maintained every cropping season, and insects can be sampled over a number of seasons. And we could have a picture about the general pests, insect pests of a given area. Now, monitoring techniques, some of them use light and the suction traps, especially what is done at research stations. We also have insect-specific traps, and insect counts on crops, which can be done. We can identify stages and the forms of the insects. Sometimes we can use what are known as peg boards. This is a simple board with holes where the farmer can put some markings using some pegs to indicate the number of insects or insect developmental.
Hello. I thought it was my network. Well, I think Doc is no longer with us.
I said I'm still connected and I can hear you very well. Grace nawimbai. Ngati exit shamwari ndezvekwawo zvekuzotitsvaga wanozotsvagawo that I don't think tine exam anytime soon.
Because my cases are COVID. Kubasa kwedu kwakabatwa almost 50 people.
Wazviona manje.
You can
enda kuexita inogara mugroup guys ndozotaura nemangwana ndakuenda
Sauraina dhuku yenyu. Iri bhogre. Iri bhore katinzwa kuti vanoti kuti ndofunga kusinawo network kwavo. All right. Iri bho.